Good afternoon. Can you hear me? Raise your hands if you can hear me at the back. Very good. Welcome. My name is Andrea Olgiati. I'm a principal engineer with AWS. And I am joined by Michael Chi, who's the director of engineering for the National Football League Next Gen Stats. We're going to be talking about machine learning, and we will be talking about Amazon SageMaker and how to build, train, and deploy ML models. We're going to be having a brief review of SageMaker, what it is, what it does, how it works. And we will describe the various ways in which customers like you can use Amazon SageMaker. We'll be talking about deployments and how to take machine learning models and deploy them at scale. And we will then talk about autoscaling, which is the art of how to grow and shrink your capacity to accommodate the changing needs of your business. And lastly, we will be talking about a real story of how Michael and his team implemented next-gen stats using Amazon SageMaker. Let's start with a broad description of the Amazon machine learning stack. This stack is catered for people who have different backgrounds, different needs. And we're going to start by describing the top level of the stack. These are the AI fully managed services. These are services that provide computer vision, speech, language, and chatbots, contact center tools based on machine learning for every developer. Now, the interesting thing about this level of the stack is that developers don't need to understand machine learning. They don't need to be experts. We at AWS have built a complete service, a complete solution for very, very, very common needs. I'm going to start by describing the recognition stack, which provides computer vision at scale. Recognition allows its customers to do object detection, face recognition, text, and there's a whole bunch of tools, content moderation, that AWS users have access to just at the click of a button. We have done the work of creating all these tools for images and for videos that you can integrate into your system. We have speech generation like Polly that can now speak in multiple languages, multiple dialects, multiple accents, and transcribe that allows AWS customers to actually to recognize spoken words and spoken language. We have translate and comprehend that allow translation between languages and understanding the semantics of what is being written. And we have systems like Lex that allow chatbots and conversational interfaces to be built. Again, this is all without any understanding of machine learning. This is for those developers that have these particular needs. Now, we also understand that not everybody's needs are covered by these techniques, by these technologies, by these services. For that class of developers, we're going to be, we built and delivered SageMaker, and that will be the main topic of this talk. So we will get to that in a second. Let's jump below to the engine that powers all this technology. We at Amazon have made a significant investment with separable teams on the frameworks, the machine learning frameworks that are evolving so rapidly that power all this technology. TensorFlow, MXNet, PyTorch, Chainer, the higher level interfaces on top of them like Gluon and Keras, and the systems to orchestrate them all like Horovod. All these run on the Amazon EC2 instances that are either CPU-powered, like our C5 family, or GPU-powered, like our P3 family. And you, as a developer, have access to all this stack of technologies at whatever level makes sense for you. And we're going to jump right into SageMaker, and we're going to really talk about how SageMaker can help you build, train, and deploy machine learning models. OK? So let's start with one statement. ML is complicated. I believe so. If you believe so, raise your hand. It's complicated. There you go. I see a few hands. It's complicated because it encompasses a bunch of steps, a number of steps, each one difficult in its own realm, in its own complexity. From data preparation to the choice of algorithm, to the management of environments for training, the tuning, the deployment in production. And there's a continuum that goes from science to engineering. And our customers told us that this is hard. And so we built SageMaker to make this simple, to really take the pain out of this process. Why? SageMaker allows a one-click model training of machine learning models, and one-click deployment. No longer do you have to provision your machines and group them together. SageMaker does all this for you. SageMaker has built-in algorithms that work at 10x the speed of other implementations of the same algorithm. These are some very common algorithms, and Michael will talk about one of them later on. These are real live algorithms that can solve concrete business problems for you. Not only do these algorithms have incredible speed, but they also scale out to the real business needs, to the real data set that all of you have to deal with. All this allows SageMaker customers to gain predictive insights into the decisions that they need to make for their business. And again, Michael will describe one such case. So, as I said earlier on, there are 3 steps: build, train, and deploy. And we will start with building. Building, the build part of SageMaker allows customers to instantiate notebooks on managed instances with all the right versions of all the right frameworks installed for you. SageMaker takes away the pain of managing all these instances and allows data scientists to focus on the problem at hand. It allows them to call APIs, call other systems from the device, from the instance or from other devices. And it allows a complete development environment. Think of it as an IDE for machine learning. Once an algorithm has been created and it's been tested, then SageMaker has facilities to manage it, to manage the training of it, manage all the machines that you want to use during the training phase. And this can be a significant number of high-power GPU instances. SageMaker takes care of all that for you. It takes care of the distribution of data. It takes care of the high-performance I/O. Often the data lives in S3, and there are several innovations that SageMaker brought to the table to bring this data into your training cluster efficiently. Now you have a model. How do you deploy it? How do you put it into production? Again, one click, one command allows you to take this model and send it to endpoints for actual live traffic. Not only can you do that, but you can also adapt your capacity to the very needs of your business. And we're going to talk about that. You can test different models. You can swap them in real time. You make one work and then see how it works and then go back to the previous one if that's not what you'd like. So again, looking again at the features, we have algorithms designed for speed and scale. And these algorithms encompass supervised learning, unsupervised learning, computer vision, and NLP. These are very easy to use. We created them. You can use them to train your own models as a baseline. But if that's not enough, if you want more control, you can bring your own model. You can write your machine learning models in your favorite framework, and we support TensorFlow, PyTorch, Chainer, and MXNet. You can write as little as 20 lines of Python code. Put this code in your notebook and start training. All of this is open source. All the infrastructure is open source, and you can also use it on your laptop using what we call local mode for testing, so that you have an even faster cycle of iteration. If this is still not enough for you, you can bring your own Docker model. You can build it using whatever tool you like. You can use whatever language you like. You can push this Docker container to a registry and then tell SageMaker to use that container. And SageMaker will use it as if it were a native container. And you can use whatever language you want, R, Java, Julia, if you're so inclined. While you're doing all these three things, you can also use automatic model tuning, which is something that we call hyperparameter tuning, which uses machine learning to choose the best machine learning model for your business. You can tell the system to find in the space of all the possible models, different learning rates, different regularizations, whatever you want, different number of layers. Hyperparameter tuning allows you to find the best model for your business. And it works with all the three modes of operation that I just described. Okay? So for the rest of this section, we're going to talk about the third part of the pipeline. Build, train, deploy. We're going to focus on the deployment. We're going to talk about how one can deploy a machine learning model at scale in real time. The key concept that we need to use here is that of endpoint. An endpoint is a RESTful API endpoint that allows clients written in any language, of course, to obtain predictions, whatever predictions you may want. And again, Michael will describe some of those. These endpoints are scalable. They have high throughput. They have high reliability. The whole AWS infrastructure and the whole management of a fault-tolerant system is delegated to SageMaker. And all you have to do is say, I want to build an endpoint. I want it with this much capacity. I want it of this type. I want it with this model. And SageMaker manages all that for you. You still with me? OK. So let's dive straight in. Let's look at some code. This is the basic command that you will need to execute to create a model in SageMaker. You have to say, I want to create model 1. And I want it to be the association of a container, which describes the code that you're going to execute, and a data for a model, which is the parameters that your model is going to have to execute on. You put all these together, and what you are telling SageMaker is that you want to create a system that merges all these things together and creates a model called Model 1. You also have to pass an execution role to make sure that the right permissions are propagated. Now, the other part is, now that I have a model, I want to tell SageMaker what kind of infrastructure I want to serve that model. And we call that an endpoint configuration. Think of it as a blueprint to create an endpoint. And in this case, we are calling that configuration model 1 config. And we're saying, I want to base it on a particular instance type, ML, M4 extra large. I want to start with 2. And I want this particular system to serve model 1. And there's something else about the weights, which we're going to talk about in a second. So once you have these two things, you have a model, you have a blueprint for how to deploy this model, you can actually deploy this model. You can call a create endpoint verb, which will take the configuration and that you have specified, which internally refers to the model, and will create an actual endpoint that you can now start calling using the SDK, which comes in multiple languages. So far, so good. So now you have a living, breathing endpoint that you can start calling. But life doesn't stop there. Your business doesn't stand still. Things will change. Your scientists will say, hey, I have a great new model that I want to deploy in production. You now have traffic. How do you make that happen? How do you test this new model? How do you switch it? We have this concept of blue-green deployments, which allow you to deploy essentially two versions of two different models. And we're going to talk about how these models can differ from each other. And you can also be behind the same endpoint. so that you can take traffic and redirect it to one of the two fleets and kind of bring them up and down, turn them on and off as you wish. You do so by saying, hey, I want to create another model. And a very typical usage of this is to say, I want to reuse the same container, but now I have an updated set of weights. That's a very common thing to do here. But this is not the only thing that you can do. You can also say, hey, for the same business problem, I want to create a completely new container and run it on a completely different set of weights. You can do that too. You create another endpoint configuration that is just like the first one. It just refers to a different set of weights. And now you say, OK, now update. And behind the scenes, the machinery in SageMaker updates the endpoint and starts serving traffic using the deployment schedule that we saw earlier on to the new endpoint. Now, this all works well if you're sure that you're sure that you're sure that your model works. Sometimes you want to do something different. Sometimes you may want to have multiple versions of the same model running at the same time and have finer control of what's going on. You may want to try different algorithms. You may want to switch from XGBoost algorithm to a neural network, and you want to test them side by side. So another way to do this is to change the endpoint configuration so that now we have both models present. So what this blob of text says is that I want to create an endpoint configuration that has both models. One is model 1, one is model 2, and they have these two variant names. And the first one takes 95% of the traffic, and the second one takes 5% of the traffic. And they both start with 2 instances each, so that traffic will be redirected in a manner that meets that split that you specified there. So now you have 2 models running at the same time. And again, they could be on the same instance type, they could be on different instance type, they could be completely different models. That's completely up to you. So once you have this configuration, you update, right? That's a companion to the creation of an endpoint. It's the updating of an endpoint. And again, your endpoint stays the same, but what now you're doing is you are creating this configuration that has both systems active at the same time. Once you're happy that Model 2 meets your needs, what you can do is you can say, OK, I'm going to start turning down Model 1. You can change the desired weight of Model 1 from 95 to 5. So now each model will take 5/10, i.e. 1/2 of the traffic. And you have them both. And if you're happy, over time you can say, hey, I'm going to turn Model 1 off completely, or maybe leave it running at very low capacity, whatever your business needs are. So now that we talked about models and how to swap them and how to make them seamlessly integrate with each other, we're going to talk about scaling and how you can take this system that we just described and make it meet your traffic, your traffic needs. SageMaker has a very rich vocabulary that allows you to determine how, if, and when endpoints should be scaled up and down. And for the next few minutes, we're going to go through a couple of scenarios that I think are interesting. You can start from the console. That's very easy to use. You can say, hey, I want to use these many instances between 2 and 5, if I can see correctly. And you can say, I want to achieve these many invocations per minute, per instance per minute. And if the traffic goes up, I want the number of instances to go up to this maximum limit. If the number goes down, I want to have a cooldown period so that I don't just drop immediately, but maybe I let some instances be alive for a few seconds or a few minutes, and then turn them off as my traffic decreases. So why do you need this? This is the reason why. Traffic follows patterns, right? Here you see a traffic that follows a daily pattern, that's kind of high frequency, but also a growth pattern. You see the traffic seems to be increasing between September and October. This is just an example, but I'm sure each one of you will have their own needs in terms of how to manage increases and decreases in traffic. Sometimes these patterns are known, sometimes they are not. Assume that, for instance, you are working on a news site and some kind of breaking news happens and you want to react to that. You cannot predict that. That's just life. And the automatic scaling policies of SageMaker allow you to react to that. And we're going to go through some of those. So this is what automatic scaling looks like in action. This is a graph that shows over time traffic going up and down. And the blue line that you see is the total number of invocations over a period of time for a particular service. And at some point, auto-scaling kicks in, and a new set of instances is added to the fleet. And the load balancer that's in front of this is informed of these. And it allows the traffic per instance, the invocations per instance, to decrease to a value that you would like. The number of invocations per minute, number of invocations per second is very simple to think about criteria. How many requests am I seeing? That's very common, very useful, but sometimes you want something else. Sometimes you want metrics that you cannot quite, that are not quite that. SageMaker allows you to tailor the auto-scaling requirements of your endpoint to your needs by using CloudWatch metrics. You can use whatever is emitted to CloudWatch metrics, to trigger scaling up and down. That's a very simple operation that you can do from the CLI, and you can create a whole bunch of metrics that are specific to you, that will allow you, your instances and your endpoint to scale in a way that meets the need of your businesses but doesn't waste resources, because that's the ultimate goal of this whole technique. So you can create automatic scaling policies that start on that index, in this case on CPU utilization. Here we're saying, I'm going to register my endpoint, which is called endpoint, which is part of SageMaker with the application auto scaling within AWS. And I'm going to say that what I want to change is the desired instance count, and it has to go between 2 and 5. But you can also auto scale on CPU utilization, and the letters in orange say, I want to increase my instance count when my CPU utilization per instance grows to above 50%, which is a number that you can pick, and it'll be up to you and how hot you want to run your boxes. And again, we end up with something that looks like this, where traffic is increasing, but the number of invocations per box, as per the orange line, remains below a certain level as triggered by the CPU utilization. Okay, that was very technical. Thank you for paying attention. I am now going to invite you, our guest, Michael Chi, the Director of Next Gen Stats at the National Football League. Take it away, Michael.
Thanks, Andrea. Thanks, Andrea. Can everybody hear me? Can everybody hear? Okay. Hi, so I'm Michael Chi, Director of Engineering at the National Football League, where I work on Next Gen Stats. I'm going to start by talking about who we are at the league, what Next Gen Stats is, and how we've come to use SageMaker as part of our platform for creating and delivering Next Gen Stats to our fans. I'll talk about how we approach creating stats, and finally I'll talk about completion probability, which is a stat that we created this year using SageMaker. So the NFL is internationally known as American football. It's America's favorite sport. It's comprised of 32 teams from around the country with about 330 games played each season. Each week, millions of fans tune in to watch their favorite teams play the game. If you pay attention to TV rankings, each week, NFL games consistently make it into the top 10 most watched TV shows each week. Our Sunday night football broadcast on NBC had over 20 million viewers tune in to watch the game week 2. With so many viewers and with such a large fan base, it's our responsibility and mission as those who work for the league to continuously find ways to enhance the game and make the experience better for our fans. On Next Gen Stats, we do that with data. The Next Gen Stats project is known internally as the Player Tracking Initiative. We put RFID tags on all of our players and track their real-time location in all of the games. Every 1/10 of a second, we get an XY coordinate for where the players are on the field and for all of the players. Using this data, we create new metrics on every play. We calculate things like, what was the offensive formation on the play? What personnel groupings were used, both on offense and on defense? Where were the receivers lined up? Over the past 3 years, we've amassed over 3 terabytes worth of data, next-gen data. That may not sound like a lot to some of you who work with big data and data science, but to the NFL, that's a tremendous amount. 1 week's worth of next-gen data is greater in size than all the historical box score and play-by-play stats dating back to 1920. Using this data, we integrate with broadcasters so that they can put stats up on TV while the games are going on. If you were watching last night's Monday Night Football game, before every play, ESPN puts up which players are on the field. If you got out to one of the games this season and went to the stadiums, you might have noticed that on the scoreboards, on the jumbotrons, they're putting up graphics with next-gen data. So the Player Tracking Initiative is a fairly new initiative for the league. When we first started off, we hired our team was pretty lean, and when we first started off, our team was pretty lean. We hired a team of very talented individuals, but what we lacked was data science experience. So when we talked to our friends at AWS and they introduced SageMaker to us, we were really excited. SageMaker provided a way for a team of engineers to start using the tools of data science. Here's a diagram of how we deliver next-gen stats to our fans. Everything that we do is deployed on AWS. As inputs to our platform, we have the tracking data that's coming from the stadiums, and we have the traditional stats, the box score and the play-by-play. We run a DCOS cluster on about 30 EC2 instances that are configured in an autoscale configuration, and we use Kafka as our message broker. We store our data in multiple data sources, but we use MongoDB as our primary data source for the tracking data. Once all the data comes through our platform, we publish it to Kafka, and it's run through a pipeline of over 100 processors that operate and create metrics on every play. This architecture is designed for speed. So once the play is over, we're able to calculate all these metrics within a second of the play ending. Building models and deploying on the SageMaker, we deploy them as API endpoints. And we create a processor that and place it in the right place in the right sequence in the pipeline to make the inference to the SageMaker endpoint and save the next-gen stat to our database and make it available to our fans. SageMaker provides us a way to use machine learning and deploy models and make those calls without changing much of our architecture. So at the League, there's two ways that we think about how we create stats. Derived metrics, and there's rule-based stats. Derived metrics are simple derivations from the tracking data. A stat like air yards, which measures and quantifies how far a quarterback throws the ball beyond the line of scrimmage. If you have the tracking data and you know where the receiver caught the ball and you know where the line of scrimmage, it's a pretty trivial problem to solve for. Rule-based stats are ones that are a little bit difficult are more algorithmic and harder to solve for us. Take who covered who, for example. It's a coverage stat saying, if I'm a receiver, which defender covered me on every play? How would you approach solving that kind of a problem using tracking data? You might start off by saying, if I'm the receiver, which defender did I lined up against me? You might take it a step further and say, over the course of the play, which of the defenders had the shortest average distance to the receiver? And then you might say, at the time that the ball was thrown, which defender was closest to the receiver? And if all three of those match, you're pretty confident in the stat. But what we've learned from the tracking data and the game of football, there are certain nuances where that doesn't always play out the way it does. There's, for example, what if the receiver is lined up in trips and bunched on the left, which means the receiver has there's three receivers all within 1.5 yards of each other? Or what if the defense is not playing man-to-man, they're playing zone? You can start to see where these rule-based algorithms start to break down. Now that we're starting to use machine learning on SageMaker, we have a new tool and a new approach to solving these more difficult problems. If we're able to use the data and train a model to learn these nuances in the tracking data, we can approach the problem differently and in a better way. To solve for all these edge cases and write code for every edge case that we come across, it makes the code more complex every time we add a case. And then it just becomes unmaintainable. So with SageMaker and machine learning, we also have a new type of stat that we can create. We can start using historical data. We can start to predict what might happen on the next play. Take completion or we can also quantify how difficult a pass is to complete. Take completion probability, for example. This is a stat that we created this year. The purpose of it is to do exactly that. Quantify, given different parameters that are happening on a passing play, how difficult is a pass for the receiver to complete. For this, we use the XGBoost algorithm built into SageMaker. We split our data into 70, 20, 10, train, validate, and test sets. And using SageMaker's automatic hyper-tuning parameters, we're able to train and validate a model and return a best performing model. These are some of the features that go into completion probability. And if you look at them, they make sense. Receiver separation. How close is the defender from the receiver? Basically telling us, is the receiver covered or not? Air yards, air distance. If you're throwing a pass further down the field, those are generally harder to complete. We trained completion probability using 35,000 passing plays over 2 years. We ended up with 11 key features, And what we found after we trained and validated a model, that you still have to test the 10% that the model has not seen. And you have to validate and see if the model is performing to your needs. And so with completion probability, that's quantifying how difficult a pass is. And for us working at the NFL, we get to watch a lot of football. And we're able to tell, and we're able to train our eyes to see when a pass is made, a 50-yard pass is made to the sideline, and there's two receivers on the receiver, it's a pretty difficult pass. And so up front, you have to decide what your criteria for the acceptance of that model is. So at this time, I'm going to show a video of completion probability that you might have seen on Sunday Night Football in our partnership with AWS.
Super Bowl 52. As time ran down in the first, Nick Foles was about to complete one of the most improbable plays of the game. With each tick of the clock, AI from Amazon Web Services processed thousands of data points to generate real-time insights, proving that a 19% chance was all Foles needed to change the course of history. Welcome to the next generation of football.
So our initial approach with the completion probability wasn't really an ML-based approach. This was before we even knew about SageMaker and had that as a tool for creating new stats. We tried to create a function that would take in different features of a play, apply different weights, and output a number. But what we realized that's very subjective, and it's not using the data, and it's not really trustworthy. Some of the other early lessons before we used SageMaker is just that since we didn't have the expertise of setting up servers in an environment for training the models, we were doing these on our laptops, and it was very inefficient, and there wasn't a good way to share the results of our model training from with each other. And so SageMaker with the Jupyter notebooks and being able to run those in the cloud makes it a lot easier to share and collaborate on different models. So, in my opinion, one of the takeaways from our story with SageMaker is that it really allows a team of engineers who are very smart and understand their data very well to use the tools of machine learning that are more complex and tackle problems in different ways. It also allows us to deploy our models in an environment that's familiar to us, being on AWS. Thank you. That's all I have.
Thank you, Michael. That was very interesting. Earlier on Sunday, I asked you if you could make the 49ers win. You said that's next year's project. But yes, Michael is one of the customers of SageMaker that has found the versatile platform to build, train, and deploy machine learning models at scale. And the thing that's interesting in his story is how a team like Michael's was able to integrate this whole pipeline into a complete system that was put into production without having the expertise of the data scientists that Amazon used to put these XGBoost models together. And you can try SageMaker yourself. There's a link. You can try building models. There's sample notebooks that you can execute top to bottom. Everything is done for you. Feel free to try it out. Thank you.